Hello, my dear students. In this video, I am going to discuss uh, current pattern model questions from the topic calorimetry. Now, the basic principle of calorimetry everyone knows. Heat lost by a hot body will be equal to heat gained by a cold body. Principle of calorimetry actually represents law of conservation of energy. When you bring different substances with different temperatures and make them in physical contact, then we can term it as a composite system. So when different temperature bodies are brought into close contact, some of them will lose heat energy and some others will gain energy. So as a whole, we can say that the net change in energy of that system will be always zero. That means heat lost by one body will be absorbed by another body. So there is no change, no loss. So that is the meaning of the sentence written here. Net change in energy of a composite system is always zero. So this concept can be well understood by the first example here. Three bodies of same material and having say masses m, m and 3m are at temperatures 40, 50 and 60 degrees Celsius respectively. If the bodies are brought in thermal contact, the final temperature will be. So in this type of problems, you have to assume that the three bodies are getting the same final temperature. Actually, they are going to get the same final temperature and assume that all of them absorb heat energy. So this is actually a shortcut trick. Assume that all the three bodies absorb heat energy. Now the interesting thing is that when a body absorbs heat energy, its temperature rises. That means all of them, their temperature is increasing to say some final temperature capital T. So that temperature we have to find. So let the final temperature be capital D. Let the final temperature of the mixture. Here actually not liquid or gas, just they are telling three bodies only. So let the final temperature be capital T. Now we can apply the calorimetry principle. I am going to write here. So the heat absorbed by the first body is represented by the relation m into S into final temperature minus initial temperature. So T minus 40 plus heat absorbed by second body can be written as m into S into T minus 50. Because each body have the final temperature capital T. Plus last one 3m into S into T minus 60 equal to 0. So net change in energy is equal to 0. That concept I have written here. Now in all the terms you can cancel out ms, ms, ms. Now what is left is T minus 40 plus T minus 50 plus 3T minus 180 equals 0. And on solving you get T equal to 54 degrees Celsius. 54 degrees Celsius. So first option is our correct option. Now we can move on to second example. 80 gram of ice at 30 degrees Celsius is poured on a large block of ice at 0 degrees Celsius. The mass of the ice that melts is. So here we have to note this point. Large block of ice. And already we know that ice is at 0 degrees Celsius. So 80 gram of, actually not ice, it is water. 80 gram of water 80 gram of water at 30 degrees Celsius is poured on a large block of ice at 0 degrees Celsius. Now, we know that when we pour water into ice, heat will be transferred from water to ice. So, in this type of questions, you have to think like this. Here it is 80 gram of water. We have to think like this. 80 gram of water at 30 degrees Celsius. 80 gram of water at 30 degrees Celsius. Now, when it becomes 80 gram of water at 0 degrees Celsius, you have to think like this. How much heat is released? How much heat is released? So, heat released is given by M into S into delta T. This released heat is absorbed by ice for its melting. So, we can write like this. Q released by water. Q released is equal to Q released by water is equal to Q absorbed by ice. That is calorimetry principle. Q absorbed by ice. What is Q released by water? Mass into specific heat into delta T. Mass is 80. Specific heat is 1. Delta T is 30 minus 0 and I am straight away writing 30. So this much amount of heat is released by water. That water is absorbed by ice for its melting. So it's a large piece of ice. So the complete ice will not melt. Only M, we can assume that let M gram of ice melt. So in such a case we can write, when ice melt, we have to use the relation like this, M into latent heat. That means 80 into 30. That means 2400 calories is equal to mass into latent heat. Latent heat is 80. Latent heat of ice is, or latent heat of fusion, that's the correct word. So latent heat of fusion is 80. So what is the answer? M equals 2400 by 80. And our answer is 30 gram. 30 gram. So first choice is our correct choice. Now we can move on to question number 3. It's an interesting question. A tap supplies water to 100 degrees Celsius and another tap supplies water at 0 degrees Celsius. The amount of cold water required to be taken so that we get 20 kilogram of water at 25 degrees Celsius. So in this question, we need amount of cold water to be taken. So that means amount of cold water means from the tap supplying water at 0 degrees Celsius. How much amount of cold water we have to take? So we can visualize the situation. First, you think like this. These are the two taps. These are the two taps. So water is coming from two taps. One is at 100 degrees Celsius. One is supplying water at 100 degrees Celsius. So water is coming out. Okay. Now another one is supplying water at 0 degrees Celsius. Now these two taps, you imagine that these two taps are filling a big water tank. You have to think like this. Now we require, in this water tank, we require 20 kilogram of water at 20 kilogram of water at 25 degrees Celsius. This is our requirement. So this is the question. This is the situation. So this is the water level. You have to imagine like this. So it's a big tank. These two taps are supplying water to this tank. So our final requirement is 20 kilogram of water at 25 degrees Celsius. So question is that how much water, that means amount of cold water required to be taken. That means from the 0 degree Celsius tap, how much amount of water we have to take so that totally we get 20 kilogram of water at 25 degrees Celsius. So we have to imagine that we are taking m kilogram of water. M kilogram of water. So from the hot tap, so this is our cold tap and this is the hot tap. So we are taking m kilogram of water from the cold tap. That means from the hot tap we have to take 20 minus m. Why 20 minus m kilogram of water? Why? Because 20 minus m plus m, then only you will get the answer as 20. That means you require only 20 kilogram of water from both the pipes. So from cold tap we assumed m kilogram, then definitely from the hot tap it will be 20 minus m kilogram. Now we are going to apply calorimetry principle. What is calorimetry principle? Heat lost by a hot body is equal to heat gained by a cold body. So here from the hot tap the water is coming and it is going to lose the temperature or it is going to lose the energy. So I am going to write that in equation format. So heat lost by the hot tap I am writing 20 minus m into 1 into delta T. Delta T is because our final temperature is 25. So 100 minus 25. That is the temperature difference. This is the heat lost, which should be equal to heat gained. So heat gained by water from the cold tap. So 20 into 1. Or you can take S also. Actually in CGS system we are taking specific heat as 1. Even if you take here because everything mass is in kilogram, so it's better you can write here S, no problem. Here also you can write S because from both sides it will get cancelled out. We don't have to tension about that. So 20 into S into, then temperature difference is 25 minus 0. So heat lost by hot tap, water from hot tap is equal to heat gained by water from cold tap. So that is written in equation format here. Now you can easily simplify it. From both sides you can remove S. Now what is left? 20 minus m into 100 minus 25 is 75, which is equal to 20 into 25. Now it's very simple. 25 into 3 is 75. Now we can write 20, or you can write like this, 60 minus 3m equals 20. Or you can write 3m equals 80. Okay, now here we have to notice that this is not 20, it is actually m. Because m kilogram is water is coming from the cold tap. So m into S into. Now here also it comes m. That means 25 into 3. Here the right hand side it is m. So 60 minus 3m equal to m. That means 60 equal to 4m. Or m is equal to 15 kilogram. That is the correct answer. So our choice is last choice. It is the correct answer. Now we can move on to question number 4. A lead ball moving with a velocity v strikes a wall and stops. If 50% of its energy is converted into heat, then change in temperature is. So here we have to find change in temperature delta T. Now when a lead ball is moving with a velocity, that means it is possessing kinetic energy. So half of its kinetic energy is converted into heat. So we have to think like this, half of kinetic energy, that means 50% of its energy means half of half mv square. Now in that answer choice, if you look, you can see in all the terms J is present. It is actually mechanical equivalent of heat, Joule's mechanical equivalent of heat. It is actually a conversion factor. So half of half mv square. This much of kinetic energy is converted into heat. So half of half mv square by J. We have to write like that, including the conversion factor. So half of half mv square by J is equal to ms delta T. So m into s into delta T. Now we can cancel out common terms. So m cancelled and we want delta T. So delta T is equal to v square by 4js. This is the right answer. So in this question specifically we have to know this relation. That means J is equal to W by Q. That's the relation. Here work done is converted into kinetic energy. You can think like that. J is equal to work done is change in kinetic energy, because after striking the wall it is stopping. So change in kinetic energy is half mv square. But here 50% of that is only considered. So half of half mv square by Q, or you can say Q is equal to 1 by 4 mv square by J. So that concept I have taken here. Please remember it. This concept I have applied here. Next comes our fifth question. Heat is supplied to a certain amount of ice at a constant rate for 9 minutes. For the first 1 minute, the temperature rises uniformly with the time. The temperature remains constant for next 5 minutes, and after that, temperature rises at a uniform rate for last 3 minutes. Specific heat of ice is given and latent heat of fusion of ice is also given. If the ratio of magnitude of final to initial temperature is P degrees Celsius, then find the value of 4P. It's a very interesting question. So we can focus on the first part of this question. Heat is supplied to a certain amount of ice at a constant rate. Now, constant rate means in our mind, that is the first point it should come. We can take like this: in 1 minute, or you can say in every 1 minute. We have to assume like this: in every 1 minute, lambda calories of heat is supplied. Constant rate. In the question, the word is given like that, constant rate. So we can assume like this: in every 1 minute, lambda calories of heat is supplied. Lambda calories of heat is supplied. Now we can look into the question. For the first 1 minute, the temperature rises uniformly with the time. So we are giving heat to ice. So in 1 minute, the temperature is rising. So we can think like this: heat received by ice in first 1 minute. Heat received by ice in first 1 minute. In first 1 minute. That means we can write it as Q1. So Q1 is equal to, we can straight away write lambda into 1. So when ice is getting heat and its temperature is increasing, then it indicates ms delta T. So m into s into delta T. That means lambda equals m into, we don't know exactly what is the value of mass. Let it be m. M into 1 by 2 into delta T. Delta T means initially its temperature we don't know. Final temperature is 0 degrees Celsius minus Ti. Initial temperature Ti. So this is equation number 1. So ice was at some temperature Ti. Now by absorbing this temperature, heat energy, its temperature increased to 0 degrees Celsius. You have to think like this. So this is ice. Ice was initially at Ti degrees Celsius. So we supplied heat energy Q1. Then it became ice at 0 degrees Celsius. That is the concept behind the equation number 1. Now ice is at 0 degrees Celsius. Now we have to think about the next 5 minutes. See the question. What is given in the question? The temperature remains constant for next 5 minutes. When temperature is constant means there is a state change or phase change. Ice is going to get converted to water. Ice at 0 degrees Celsius will now become water at 0 degrees Celsius. So we can write that. So in the next 5 minutes, heat absorbed by ice is, we can name it as Q2. So Q2 is equal to lambda into 5, because in 1 minute lambda calorie of heat is absorbed. So in 5 minutes 5 into lambda calorie will be absorbed, and using that heat it is going to convert it to water. So we can write m into 80, state change equation, mass into latent heat. So from this we can write lambda is equal to 16m, because 5 into 16, 80. So lambda equal to 16m, equation number 2. Now in the last 3 minutes, heat absorbed by, now it is water. So we can write heat absorbed by water. Is Q3 equals lambda into 3, which is equal to, again we have to use the concept of ms delta T. So m into specific heat of water is 1 into delta T. Delta T is final temperature minus 0 degrees Celsius. That is the initial temperature. That means we can write Q3 equals 3 lambda equals m into Tf, or 3 lambda equals m into Tf, equation number 3. So 3 relations we got: equation number 1, equation number 2, equation number 3. Now from these 3 relations, on solving we get, that means solving means left hand, see from equation 1 and 2, left hand side is same, so you can equate right hand side, and using that value you can find Tf. So we get Ti equals minus 32 degrees Celsius and Tf equals 48 degrees Celsius. And in the question that ratio is given. It is given as P. So P is equal to Tf by Ti. So you have to take the modulus because ratio we are considering. So 48 by 32, which is equal to 3 by 2. Now they are asking for 4 times P. So 4 into P equals 4 into 3 by 2, which is equal to 6. So 6 is our required answer. So which choice we have to select? First choice we have to select. It is the correct answer. Now we can look into the next question. Question number 6. We have half a bucket of water, 6 liter at 20 degrees Celsius. If we want water at 40 degrees Celsius, how much steam at 100 degrees Celsius should be added to it? So here it's clear that steam at 100 degrees Celsius is going to lose the heat and water will be going to get heat energy. It absorbs the same amount of energy. So heat lost by steam is equal to heat gained by water. That is the concept. So in this question, we have steam at 100 degrees Celsius. So it's better to think like this. We have steam at 100 degrees Celsius. Now it is going to lose heat. So steam at 100 degrees Celsius will get converted to water at 100 degrees Celsius first. So there we can write the relation M into latent heat of vaporization. Now water at 100 degrees Celsius, it will become water at 40 degrees Celsius. Now at the same time, 6 liter of water at 20 degrees Celsius will also becomes water at 40 degrees Celsius. So we can think like this. 6 liter of water at 20 degrees Celsius, it will absorb this heat. So first part the heat, let it be Q1, and here the temperature change is there. So you can write ms delta T concept. So M into S into delta T, which is equal to Q2. Now 6 liter of water at 20 degrees Celsius will also becomes 6 liter of water at 40 degrees Celsius. 6 liter of water at 40 degrees Celsius. So let the temperature is equal to Q3. So according to calorimetry principle, we can straight away write Q1 plus Q2 should be equal to Q3. Heat lost by a hot body is equal to heat gained by a cold body. Now we can write amount of steam converted. That's our requirement. How much steam at 100 degrees Celsius should be added to it. So we can write M into 540, because latent heat of vaporization is 540, plus M into S into delta T. S is 1. Specific heat of water is 1. Delta T is 100 minus 40. That temperature difference magnitude only we are taking. So 100 minus 40 equals 6 liter. 6 liter means 6000 centimeter cube into 1 specific heat of water into temperature difference 40 minus 20. Now on solving we get M equals 200 gram. M equals 200 gram. So our correct choice is first choice, 200 gram. So now we can move on to our next question. Interesting question, 7th question. 1 kilogram of ice at minus 10 degrees Celsius is mixed with 4.4 kilogram of water at 30 degrees Celsius. Final temperature of the mixture is. See, this question, when you get, here ice is there, water is there. So definitely heat will be lost by water, and that heat will be gained by that 1 kilogram of ice. Now, when this type of problem comes, there is a first step. Always do that step. The step is that you have to find how much heat is released, how much heat can be released by how much heat. Students, please note this concept. How much heat can be released when 4.4 kg of water at 30 degrees Celsius is converted to 4.4 kg of water at 0 degrees Celsius. For that, let that heat be given by Q. So Q equals ms delta T we have to use. Mass is 4.4. Specific heat of water is 4200 into delta T. Delta T is 30 minus 0. So this much amount of heat can be released by water. Now here 1 kilogram of ice at minus 10 degrees Celsius is given. So we have to think like this. 1 kilogram of ice at minus 10 degrees Celsius. It should be first converted to 1 kilogram of ice at 0 degrees Celsius. Let the heat required be equal to Q1. Now 1 kilogram of ice at 0 degrees Celsius should be converted to 1 kilogram of water at 0 degrees Celsius. Let the heat required be given by Q2. So we know that Q1 is equal to ms delta T. That means 1 into specific heat of ice is 2100 into delta T. Delta T is 10. 0 minus minus 10. Now Q2 equals, there a state change is happening. Ice is getting converted to water. So mass into latent heat of fusion. That means mass is 1 into latent heat of fusion is, we can take it as 80 calorie. I am writing it here in calorie. So 1 into latent heat 80 calories. But since mass is in kilogram, the calorie should be converted to equivalent joule format. So we can write here 1 into 80 into 4.2, which is equal to 336 joules. Now here you will get 21,000 joules. Now here the total value will be 554400 joules. So we can conclude that Q is greater than Q1 plus Q2. Q1 is here, Q2 is here. So Q is greater than Q1 plus Q2. That means after ice melts, that means 1 kilogram of water at 0 degrees Celsius will rise to a new temperature. 1 kilogram of water at say T degrees Celsius, that we have to find. So after this checking step, now we can apply the calorimetry principle. Heat lost by a hot body equal to heat gained by a cold body. Here heat is lost by whom? 4.4 kilogram of water at 30 degrees Celsius. So we can write like this. 4.4 into 4200 into 30 minus T, because the final temperature is going to be T. So 4.4 into 4200 into 30 minus T is equal to our Q1 plus Q2. Q1 is 21,000 joules plus Q2 is 336 plus 1 kilogram of water at 0 degrees Celsius will change to 1 kilogram of water at T degrees Celsius. So we can write 1 into 4200 into delta T. Delta T is T minus 0. T minus 0. Now on solving you get T equal to 8.7 degree Celsius. So your correct answer is fourth option. Now we can move on to our next question. Question number 8. Steam at 100 degrees Celsius is passed into 22 gram of water at 20 degrees Celsius. The mass of the water that will be present when the water acquires a temperature of 90 degrees Celsius. Latent heat of steam is 540 calorie per gram. So here, steam and water. So we can say that heat lost by steam. Our calorimetry principle same. Heat lost by steam equals heat gained by water. Heat gained by water at 20 degrees Celsius. So heat lost by steam. So we have to think like this. Let m gram of heat, m gram of steam. Let m gram of steam is supplying heat to water. Heat to water. That means heat lost by steam. See, first the stage by stage process, if you check, you know that first steam will get converted to m gram steam. M gram steam will get converted to m gram water at 100 degrees Celsius. So steam at 100 degrees Celsius, now m gram water at 100 degrees Celsius. Now m gram water at 100 degrees Celsius will get converted to m gram water at 90 degrees Celsius, because our final temperature of the mixture is given in the question as 90 degrees Celsius. So for this, when steam is converted to water, some amount of heat will be released. When water at 100 degrees Celsius is converted to water at 90 degrees Celsius, then also some heat will be released. So we know that Q1 equals m into 540. Q2 equals ms delta T concept. So m into specific heat is 1 into delta T. Delta T is 100 minus 90, which is equal to 10 m. Now using this Q1 and Q2, our water at 20 degrees Celsius, 22 gram of water at 20 degrees Celsius will become 22 gram of water at 90 degrees Celsius. So when 20 gram of water at 22 degrees Celsius, 22 gram of water at 20 degrees Celsius. When 22 gram of water at 20 degrees Celsius is converted to 22 gram of water at 90 degrees Celsius, heat absorbed is, let it be Q3. So Q3 is equal to again ms delta T concept, 22 into 1 into 90 minus 20, which is equal to 22 into 1 into 70. Now according to our calorimetry principle, Q1 plus Q2 should be equal to Q3. That means 540 m plus 10 m equals 22 into 70. That means m equals 22 into 70 by 550. And your answer will be equal to 2.8 gram. So this 2.8 gram is actually of steam. So steam to water. 2.8 gram of steam is converted to water. So question is total water present. So total water present is equal to Already there is 22 gram of water. So 22 plus 2.8 from this steam. So total becomes 24.8 gram of water will be inside that, or that much amount of water will be there. So answer is first option. Now we can move on to our next question. Question number 9. 50 gram of ice at 0 degrees Celsius is dropped into a calorimeter containing 100 gram water at 30 degrees Celsius. If thermal capacity of the calorimeter is 0, then amount of ice left in the mixture at equilibrium is. So they are talking about equilibrium, mixing ice and water. So equilibrium temperature is 0 degrees Celsius. Now in the question there is a clear-cut hint. Amount of ice left. That means totally 50 gram of ice is there. So complete ice is not melting. So we can assume like this. Let m gram of ice is melting. Let m gram of ice melt here. Melt in this situation. According to the situation given in the question, we have to think like this. Only m gram of ice is melting. So, for that melting, heat is supplied by 100 gram of water at 30 degrees Celsius. So, our calorimetry principle I am going to apply. Heat supplied by 100 gram water. Heat supplied by 100 gram water at 30 degrees Celsius equals heat absorbed by m gram of ice. Heat absorbed by m gram of ice. M gram of ice. Now heat supplied by 100 gram of water at 100 degrees Celsius. When it becomes water at 0 degrees Celsius, because our equilibrium temperature is 0 degrees Celsius. So this will give you the clarity. Now what we can write is that heat supplied by 100 gram of water is 100 into 1 into 30 minus 0 equals m into specific heat of ice is half 1 by 2 into delta T. Now here it is melting, so not ms delta T, we have to write mass into latent heat. Latent heat is 80. So what we get is that m is equal to 3000 divided by 80, which is equal to 300 by 8, which is equal to 37.5 gram. So this much amount of ice is melt. Question is amount of ice left. So totally 50 gram was there. So from that 50, 37.5 gram is melt. It is melted. So our answer will be 12.50 gram. So our best answer is option 1. Now comes our 10th question. Two identical bodies are made of a material for which heat capacity increases with temperature. One of these is at 100 degrees Celsius while the other one is at 0 degrees Celsius. If the two bodies are brought in contact, then assuming no heat loss, the final common temperature is. So here also two different bodies and we are mixing them. So final common temperature they are asking. So we know the concept. We are going to apply the concept. M into identical bodies. They have mentioned it as identical bodies. So I am taking mass. M into S1 into then T minus final common temperature is T. You assume like that. So T minus 0 because one person is at 0 degrees Celsius. It is equal to M into S2 into 100 minus T because another body is at 100 degrees Celsius. After mixing, their common temperature is T. I have assumed like that. Now, here there is a speciality. Their heat capacity increases with the temperature. That means S1 and S2 are dependent on temperature. So from this relation, you will get here m cancelled. So you get T by 100 minus T equals S2 by S1. Now S2 is greater than S1. So S2 by S1 is greater than 1 because S2 is associated with this 100 degrees Celsius and S1 is associated with the 0 degrees Celsius. And the specific heat increases with the temperature, or heat capacity increases with the temperature. That is the point given in the question. That's why I have written here S2 by S1 is greater than 1. So if S2 by S1 is greater than 1, then definitely T will be greater than 50 degrees Celsius. You can check it. You take any value. So S2 by S1 will be greater than 1 means you take 2 or 3. Then you will get the value for T greater than 50 degrees Celsius. So our correct choice is more than 50 degrees Celsius. Okay, thank you. So please go through all these questions in detail and practice it repeatedly. Thank you.